You're feeling pretty confident at this point about solving for resultant vectors at right angles and resolving vectors into their right angle components. Yes? Wunderbar. And as somebody in physics many years ago said, every time you say, good, I'm glad that's simple, you're about to complicate things. So, let's get down to the business of complicating things, shall we? I give you an angle. You can make a right angle of it. You can find the angle, you can find the components. Yes, you're good at that. I give you two right angle components. You can find the resultant. Yes, you're good at that. This is all Pythagoras. This is all very, very simple. What happens if the vectors are not perpendicular to one another? Then it gets a little bit more complicated. Now what I'm going to tell you is that what we're doing now, which is this chunk is called non-perpendicular vectors because we're dealing with vectors that are not perpendicular. How much more obvious can we make it? This rewards good bookkeeping. If I had a big ruler, this one just is going to sound weenie. Yeah, really weenie. If I had a giant ruler to smack, if I had a 2x4, I would smack it while repeating the words, rewards good bookkeeping. Okay? This rewards precision. It also rewards visual learners. If you're not a visual learner, pick up some tips from the visual learners around you. Color coding will save your life on this stuff. And this starts to form a basis for a lot of other things we do. So it's not so much that solving for non-perpendicular vectors is important, but you're building a skill set. You're building fluency in a skill set. You're getting to a point where it is so automatic for you to resolve multiple vectors into their components that you could do it in your sleep. Okay? So what we do in these cases, and I'm going to overcolor this, if I have two displacements but they're not perpendicular to one another, my resultant is this thing. But to find that, what I have to do is construct two other little triangles and find the overall x displacement and the overall y displacement. This all works on the idea that we can move vectors perpendicular to one another. So we're really just building multiple triangles here and then building big overall triangles. Let's go ahead and do the sample problem in the book together. It's 3C on page 95. First thing to do is always draw yourself a little compass rose at your starting point. And you don't have to draw these perfectly to scale like you did when you were doing graphic vectors. That said, doing them at something that's like crazy off scale will hurt you in the end because you won't be able to visualize what direction your resultant is going. Okay? So 35 south of east, and I'm going to make this purple. So this would be south of east. That would be 45. So I'm going to go just a little shy of 45. That's not much shy, is it? There. And I'm going 25.5. I'm going to make this bigger because it'll help. And drawing these larger rather than smaller is helpful to you. So this is 25.5 kilometers. And this is 35 degrees south of east. So I'm going to break that up into my component vectors. Well, actually, let me do the whole darn story first, shall I? Second day, walks 41 kilometers at 65 north of east. Now, I am going to draw a second compass rose. I'm going to go right to that last point there. I'm going to draw another compass rose so that I can find my second angle visually. 65 north of east, so that would be north of east. There's 45. That should be about, yeah, calling that 60 is probably reasonable. And I'm going 41 kilometers. Now, my first vector was 25, so obviously this one should be a little bit longer. Again, this is not, and this is 65 degrees north of east. Okay, so I'm going to, looking at this, I'm going to move this a little bit over more just center. The nice thing about doceri that you can't do on paper. When doing these problems, I actually would advise you to just plan for a whole sheet of paper for every single problem, because you want to leave yourself lots of space. If you can do your drawing in the center, that usually helps because it leaves you lots of space around the perimeter to put in your calculations. So I'm going to draw in my first triangle. So on this first leg of travel, she has a delta x displacement. We're going to call that delta x1. She has a delta y displacement. We're going to call that delta y1. And no, my vectors don't meet because I screwed up my lines. There. I'm going to fix this one. Okay, so I've got delta x1, delta y1. On that second leg of travel, I have delta x2, and I have, again, my vectors are terrible, but here, see if I can do that. There we go. And I have delta y2. So if I'm looking for my overall resultant, where is this thing? I'm going to draw this in orange. This is the tail of my first vector. This is the head of my last vector. So I should definitely move that out of the way. So my overall resultant is that. Sure is pretty if you got a lot of colors. And I have colored pencils. If you want to use them, you're welcome to. This can be simplified significantly, and we will. But the thing to pay attention to is the fact that delta x1 and delta x2 are both in the same direction. Okay, so we know the magnitude of the x resultant, and I'm going to do this as sort of a dotted line. Spacing, there we go. So that you can see the stuff under it. There's my delta x total. So that's delta x total. And there is, let me move this down. There is my delta, whoops, y total. So can you see that my resultant triangle is there? Now how is it that my delta y total is shorter than either two of my delta y's? Well, glad you asked. Because if you notice, delta y1 is down and delta y2 is up. So those are going to be in opposition to one another, and you're going to handle that using signs. Okay? You can handle it using signs, you can handle it just treating them all as positives, but then knowing that you have to subtract some. Either way works. Now what we're going to start to do, here's how I always start these. If I can visualize the triangles, then I can do this. Oops. And I am color coding because I am a super crazy visual learner, so I love these kind of problems. The resultant is equal to the square root of delta x total squared, oops, plus delta y total squared. What that does is it serves to remind me that I'm looking for the total x displacement and the total y displacement. It sets up a logical sequence of events. So, I mean, yeah, this is the end, but it sets me up to know that I have to go compute my total delta x and my total delta y. So now, I'm going to get rid of this altogether because I have all the information I need. I'm going to set this over here as a note to myself. I'm going to set this one over there as a note to myself. And I'm going to start the process of figuring out those displacements. So, Okay, so I'm going to start off by just looking at my first displacement. And what I know, here's my delta y1, we'll start with that, is that the sine of 35 degrees is going to equal, because that's opposite, over adjacent, which is equal to my delta y1 over 25.5 kilometers. I'm going to actually get rid of this. I just wanted to make sure you could all see where that came from. So the sine of 35 times 25.5 km is equal to delta y1. What I tend to do with these problems is I leave all the numbers as positive, but I put these little arrows in for myself as sort of cheaters. You can handle it a different way. That's a method that works well for me. Let's do the delta x1. We have the setup for finding delta x1. We'll get a raw number. Okay, so we've got the raw numbers for delta y1 and delta x1. I'm going to mention this. When I am grading these things, if you would be so kind as to circle these intermediate answers, that is enormously helpful for me, and it may also be enormously helpful for you, because that way you don't lose it on a whole page full of numbers. Also, don't round these numbers. If you're using the multi-view calculators, you can keep the numbers in there and pull them up and down. So I just write it out about 3 decimal places with a dot, 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 so that I know what I'm looking for, and then I pull them all off of here. And that's pretty easy. Okay, let's go to our second displacement. So we're now looking at this triangle, and I'm going to do the exact same thing I did with the first one, where I'm going to find the x and y components of that second displacement. And this is obviously a little bit cluttered. Writing these bigger on your paper helps to avoid that. But here's an interesting thing. What's opposite my angle? My delta y. On the other one, my delta y, oh no, they were both opposite, never mind. Ha! You gotta be careful on these, because they're not always that way. So, alright. Sine of 65 is equal to delta y2 over 41.0 km. Okay, so I've got a delta y2 of 37.158, etc., kilometers, and that's north, and I've put that arrow in to remind myself of that, and I'm going to circle this in some other color. So I've got my delta y2. Now we'll do the delta x. So cosine of 65, if I look at that, times my resultant 41.0 kilometers, going to give me delta x2. Let's get a raw number. Okay, so I've got a delta x2 of 17.37 blah 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 kilometers, and that's eastward. So both x displacements are eastward. All right. Well, here's what I got to do now. So I have those sort of set aside, and I seem to have crossed my colors there. Let me fix that. This is one of those things where if you are a visual learner and the visual cues that color provide are really helpful for you, don't do what I just did and cross your colors. Tips from a visual learner who's been fighting her own chaotic tendencies for a long time. Okay, so I've got those lined up. Now, because I started off with this little thing right here, what I know is that I need to do this. Delta x total equals delta x1, which is that way, plus delta x2, which is also that way. Delta x total equals, and that's where I'm going to actually pull these numbers. So I've got my 20.88. So I've got those written in, and using the TI multi-views, I can just go up and I get a raw answer. And again, I am leaving these unrounded. Do not round. And that is east. So I've got my delta x total. Okay. Now I want to do my delta y total. Delta y total is equal to delta y1, which is down, plus delta y2, which is up. I can use the Cartesian standard that down is negative and up is positive. That's easy enough. And I'm going to pull my numbers from here and here. So I have that set up. I'm now going to go ahead and get my raw numbers. Okay, so I have a total delta y of 22.523, etc. kilometers, and that's going to be north. Now, did I mention that these are not difficult, but they are painstaking and they do reward good bookkeeping? I want you to take a look at what I've got so far here in terms of bookkeeping. I have all my calculations that go with my first triangle. I have all my calculations that go with my second triangle. I have all the calculations that get me the legs of my overall triangle to find my resultant. And I'm not done. These are tedious. They are not difficult, but they are tedious. So now what I tend to do, because it helps me clear the sort of visual clutter, is I tend to redraw my overall triangle here so that I can see it. And I know that in that overall triangle I have a delta x of 38.21 blah blah blah. Okay, take your 4, we'll come back. Here we go. So I did a little bit of just cleaning up the page visually. Sadly, of course, you can't do that on real paper, so that's why I say give yourself a whole page for every problem. You'll probably need it. So I have all my calculations kind of color-coded to correspond to what I've got. Now it's just down to Pythagoras, because we know that r is equal to the square root of delta x total squared plus delta y total squared. So I'm going to go ahead and put that in. I have the equation for the resultant with my numbers plugged in. Let's get a raw number. So I get a raw number for my resultant of 44.3638. It goes on and on and on and on kilometers. Am I done? Nope, because I got to get the what? Heading. So to do that, I'm again looking at this overall triangle, and I want this angle theta. So my opposite will be my delta y, my adjacent will be my delta x. So the inverse tangent of delta y total over delta x total will equal theta. Now I'm going to plug in numbers. So I'm showing that with my numbers put in. Okay, so I've got 30.524, etc. degrees. I have to find my heading. I have to find the directional heading on this. So I have the degrees. If I come back to this triangle that I drew myself here, and I look at putting a compass rose at the base there, this would be what of what? North of east. So when I write my final answer for this whole bloody mess, I'm going to write, with how many sig figs do I have here? 2. I'm limited by the degrees. So I am going to say that her overall displacement is 44 kilometers at 31 north of east. That's my final answer. It's messy, but it is seriously, oddly satisfying, I think. All the circling, all of the bookkeeping that goes into this, here's what I'm going to say. The most common mistakes that people make, telling you this in advance, are flipping your sign functions, solving your x and y wrong. That's easy. But then if I can go back when I'm grading your test for this chapter and I can see that you have that marked, that you used cosine for delta y, but then you consistently knew that, delta y1 went here and delta y2 went there, I'm going to take off fewer points than if I can't see it, if it's a black magical box in which your calculations exist, but I can't see what you wrote. Same thing here. If you just put the wrong numbers in here and I can't see that you knew that it was supposed to be delta y total over delta x total, that loses you more points. Because typically I'll give you a point for doing this, a point for doing this. I'll give you a point for doing this. So on these types of problems, there are a ton of intermediate points where, showing me that you know what delta x1 and delta y1 are is a point. Showing me that you have the formula for those is a point. So there are lots of intermediate points. These are worth lots of points because there's tons of work. But showing all those steps helps me if you do have a mistake somewhere in the process to give you all the points possible. That said, all of the problems here, 1 through 4, are assigned on page 97, and I'm going to give you just time to work. Page 97, 1 through 4, go.